Imagine standing on the edge of everything you know, peering into the vast unknown, where the rules of reality shift and bend. What if our universe, with its shimmering galaxies and delicate balance of life, is just one of countless others, each governed by its own unique laws? This is the tantalizing idea of the multiverse, a concept that stretches the boundaries of science, philosophy, and imagination. It's a notion that has sparked heated debates among physicists, with some hailing it as a revolutionary explanation for why our world exists as it does, while others dismiss it as a speculative leap into uncharted territory. Today we're diving into this cosmic mystery, exploring the multiverse's origins, its implications, and whether it's a bold step forward in science or a seductive dead end. Buckle up, because this journey will challenge everything you thought you knew about reality, and we need you to join the conversation. If this sparks your curiosity, hit that like button, drop a comment with your thoughts, and subscribe to keep exploring the universe with us. Let's start with the basics. What do we even mean by universe? The word once encompassed everything, every star, every planet, every fleeting photon of light. It was the ultimate container of existence, leaving no room for anything beyond. But science has a way of rewriting definitions. Today, physicists use universe to describe our specific pocket of space-time, born from a singular Big Bang some 13.8 billion years ago, as confirmed by cosmic microwave background measurements from the Planck satellite in 2023. This is our cosmic neighborhood, stretching across an observable expanse 93 billion light years wide, bounded by what we call the particle horizon, the farthest distance light has had time to travel to us. But what lies beyond that horizon? If you could magically teleport just past it, you'd likely find more of the same. Galaxies, stars, maybe even planets not too different from our own. We consider these regions part of our universe because they're connected to our space-time, even if their light hasn't reached us yet. But here's where things get wild. What if far beyond our observable universe, the fundamental rules of physics, gravity, electromagnetism, the very constants that make life possible, start to change? What if space-time itself stretches into realms so alien they feel like entirely different universes? This is the seed of the multiverse idea, that our universe is just one piece of a far grander tapestry where each thread weaves a reality of its own. Let's pause for a moment. Does the idea of other universes thrill you or make you skeptical? Drop a comment below and let us know. Your thoughts are part of this cosmic puzzle. The multiverse isn't a single concept, but a family of ideas, each born from different corners of physics. Picture a cosmic quilt, where patches of space-time operate under wildly different rules. This quilt multiverse suggests that over vast distances, the laws of physics might shift, creating regions that feel like separate universes, even if they're technically connected. Then there's the eternal inflation hypothesis, a mind-bending idea rooted in cosmology. According to this theory, our universe is just one bubble in a frothing sea of rapidly expanding space-time, where new bubbles, new universes, form constantly, each with its own physical constants. Data from the Simons Observatory in 2024 supports the idea that inflation could sustain such a process, though direct evidence remains elusive. Another multiverse model emerges from the depths of black holes. Cosmologist Lee Smolin's theory of cosmological natural selection proposes that new universes could be born inside black holes, each inheriting slightly altered physical laws from its parent universe, like a cosmic game of evolution. Then there's the cyclic universe model, where our universe undergoes endless cycles of expansion and collapse, each cycle potentially tweaking the laws of physics. And let's not forget the many worlds interpretation of quantum mechanics, where every quantum event spawns a new reality, a branching tree of infinite possibilities. For today though, we'll focus on multiverses that allow for varying laws of physics, as these tie directly to one of the universe's greatest mysteries. Why does our world seem so perfectly tuned for life? What's your favorite multiverse idea? Are you drawn to the idea of bubble universes or quantum realities? Share your pick in the comments. It helps us keep this cosmic conversation alive. Our universe is a remarkable place. Change the strength of dark energy by a fraction, and galaxies might never have formed. Tweak the mass of the Higgs boson, discovered at CERN in 2012 and measured with greater precision in 2025, and particles might not clump into atoms. Alter the number of space-time dimensions, and the delicate balance that allows stars to burn and planets to host life collapses. It's as if someone dialed in the exact settings needed for us to exist. This is the fine-tuning process. problem. The parameters of our universe seem exquisitely calibrated to produce life, and the odds of this happening by chance are vanishingly small. Enter the anthropic principle, a deceptively simple idea that flips the fine-tuning puzzle on its head. It says we shouldn't be surprised to find ourselves in a universe capable of supporting life, because we had to emerge in one that does. It's like wondering why you're standing on a lush green planet instead of a barren asteroid. Habitable environments are rare, but we're here because they're the only places we could be. Extend this to the multiverse, and the fine-tuning problem starts to dissolve. If there's an ensemble of universes, perhaps 10 to the power of 500 or more, as suggested by string theory's vast landscape of possible configurations, then it's no shock that we're in one of the rare ones where life can thrive. The uninhabitable ones? They're out there, but no one's around to notice. This idea is powerful, but it's also divisive. Some argue it's a cop-out, a way to dodge explaining why our universe's laws are the way they are. Others see it as a profound insight, suggesting the multiverse isn't just possible, but necessary to explain our existence. What do you think? Does the anthropic principle solve the fine-tuning mystery, or does it feel like a philosophical sidestep? Let us know in the comments, and if this is sparking your curiosity, hit that like button to keep the conversation going. The multiverse is a thrilling idea, but it's not without its critics. Some physicists argue it's not science at all. It's too extravagant, too untestable, too much of a departure from the rigorous principles that have guided discoveries like general relativity or quantum mechanics. To unpack this, we need to tackle two main criticisms. First, that the multiverse violates Occam's razor by being unnecessarily complex. Second, that it's unfalsifiable and leads to a scientific dead end. Let's dive in and see if these critiques hold up, or if the multiverse can stand its ground. Occam's razor, named after the 14th century philosopher William of Occam, is a guiding principle in science. Don't multiply entities beyond necessity. In other words, the simplest explanation that fits the facts is usually the best. At first glance, the multiverse seems to laugh in the face of this rule. A single universe is complex enough. Why propose an infinite ensemble of them? Critics argue that conjuring up countless realities to explain our universe's fine-tuning is like using a sledgehammer to crack a walnut. But let's dig deeper. Occam's razor isn't about minimizing the outcomes of a theory, but the assumptions it requires. If a theory naturally predicts a multiverse without adding extra postulates, the razor might not apply. Take eternal inflation. It's a model developed to explain the rapid expansion of the early universe, supported by observations like the cosmic microwave background's uniformity, measured with unprecedented accuracy by the Euclid telescope in 2025. The multiverse emerges as a byproduct of this model, not an assumption tacked on. Similarly, string theory's vast landscape of possible universes, each defined by different configurations of extra dimensions, arises from its mathematical framework, not from someone arbitrarily deciding there must be other universes. The anthropic principle complicates things further. If we say fine-tuning exists because of a multiverse, we might be introducing an extra assumption, but is it really? Historically, our instinct to keep things simple has sometimes led us astray. In ancient times, astronomers rejected the idea that Earth orbits the sun because it implied stars were so far away their parallax was undetectable, a universe too vast to fathom. In the 1920s, Harlow Shapley argued against the idea that spiral nebulae were distant galaxies, as it suggested an uncomfortably large universe. Yet today, we accept a cosmos spanning billions of light years, potentially infinite in scope. Size alone doesn't violate Occam's razor, only the complexity of the underlying theory does. So, if a theory like string theory or eternal inflation is parsimonious in its assumptions, the multiverse it predicts might not be the extravagance it seems. What's your take? Does the sheer scale of the multiverse make it feel excessive, or is it a natural extension of our expanding understanding of reality? Drop your thoughts in the comments. We're curious to hear your perspective. The second critique is thornier. Is the multiverse unfalsifiable? And does it halt scientific progress? In strict Popperian philosophy, science is about crafting hypotheses that can be tested and potentially disproved. If we can't observe other universes, how can we test the multiverse's existence? Some argue it's no better than metaphysical speculation, a catch-all explanation that says everything is possible, so why bother investigating? But this view might be too rigid. Science isn't just about direct observation, it's about building consistent models of reality using all available tools. Consider the regions beyond our particle horizon. We can't see them, but we infer their existence because our models suggest spacetime extends far beyond what we can observe. The multiverse isn't entirely untestable either. For example, eternal inflation predicts that bubble universes might collide, leaving subtle imprints in the cosmic microwave background. While 2025 data from the South Pole Telescope hasn't found such signatures, the search continues. Another test comes from anthropic predictions. Physicist Steven Weinberg used the anthropic principle to predict the value of dark energy before it was measured in 1998, a calculation refined by DESI survey results in 2024. If our universe's properties align with what we'd expect from a multiverse shaped by anthropic selection, that's a point in its favor. Far from being a dead end, the multiverse can guide research by constraining the properties we expect in our universe. Theories like string theory or eternal inflation make specific predictions about the distribution of physical constants across universes, which we can compare to our own. If these predictions hold up, they strengthen the case for a multiverse. If they don't, we refine or discard the theory. That's the scientific method in action, not a surrender to speculation. So is the multiverse bad science? Not necessarily, if it's proposed as a lazy answer to every question. Why is the universe fine-tuned? Multiverse? Then yes, it's unhelpful. But when grounded in rigorous theories with testable predictions, it's a legitimate scientific hypothesis. The key is to keep pushing for evidence, whether it's through cosmological observations or particle physics experiments at facilities like the upgraded Large Hadron Collider, set to resume in 2026. What do you think? Can we ever truly test the multiverse, or is it too far beyond our reach? Share your thoughts in the comments, and if this is sparking your curiosity, hit that like button and subscribe to stay in the cosmic loop. The multiverse isn't just a scientific hypothesis, it's a mirror reflecting our deepest curiosities and fears. When we contemplate infinite realities, we're not just wrestling with equations or telescope data, we're confronting what it means to be human in a cosmos that might be unimaginably vast. If our universe is one of countless others, each with its own rules, it challenges the stories we've told ourselves for centuries, that we're at the center of creation, that our existence is uniquely significant. The multiverse whispers that we might be a fleeting spark in an endless fire, a single note in an infinite symphony. Yet far from diminishing us, this idea can ignite a sense of wonder. It invites us to marvel at the improbability of our existence, to cherish the delicate conditions that allow us to gaze at the stars and ask, why are we here? It's a call to humility, but also to courage, to explore, to question, to seek meaning in a reality that might be far stranger than we ever dreamed. The multiverse also represents a bold frontier for scientific discovery, pushing the boundaries of what we believe is possible. It's not just about explaining fine-tuning, it's about redefining the scope of science itself. In 2025, experiments like those at the Vera C. Rubin Observatory are probing the large-scale structure of the universe, searching for clues that might hint at the multiverse's existence, such as unexpected patterns in galaxy distributions. Meanwhile, theoretical physicists are developing new models to predict how a multiverse might influence observable phenomena, from gravitational wave signatures to anomalies in particle interactions. These efforts remind us that science thrives on the edge of the unknown, where bold ideas are tested against the crucible of evidence. The multiverse, far from being a dead end, is a catalyst for innovation, urging us to build better telescopes, craft smarter experiments, and think more creatively about the nature of reality. As we stand on the precipice of this cosmic mystery, the multiverse invites us to embrace the unknown with open minds and fearless hearts. It's a reminder that the universe, or multiverse, is not a puzzle to be solved in a single video, but a journey that unfolds with every question we dare to ask. Whether you're a skeptic demanding hard evidence, or a dreamer captivated by the idea of infinite worlds, your voice is part of this grand exploration. So, let's keep the conversation alive. Share your thoughts in the comments. Do you believe the multiverse could be real, or is it a step too far? Hit that like button if this journey has sparked your imagination, and subscribe to join us as we chase the next cosmic mystery. Together, we'll keep exploring the vast, wondrous tapestry of existence, one question, one discovery at a time. The multiverse isn't just a scientific theory, it's a narrative engine, spinning tales of worlds beyond our own. Imagine a universe where gravity is weaker, stars burn out before planets can form, or one where time flows backward, unraveling the very concept of cause and effect. Each universe in the multiverse could be a story, a unique experiment in the laws of physics, playing out in ways we can scarcely imagine. This storytelling aspect captivates not just scientists, but artists, writers, and dreamers who see the multiverse as a canvas for exploring what could be. In 2025, cultural reflections of the multiverse are everywhere. Films like Infinite Realms and novels like The Cosmic Quilt draw on these ideas, weaving narratives that resonate with our longing to understand our place in the cosmos. By contemplating these alternate realities, we're not just doing science, we're engaging in a universal human impulse to tell stories, to imagine possibilities, and to connect with something larger than ourselves. The multiverse in this sense is a bridge between the empirical and the imaginative, inviting us to wonder what stories are unfolding in those unseen worlds. The multiverse also prompts us to grapple with ethical questions that ripple beyond science. If infinite universes exist, each with its own version of reality, what does that mean for our choices here and now? In a multiverse where every possible outcome occurs somewhere, do our decisions carry the same weight? Some philosophers argue that the multiverse could inspire a kind of cosmic nihilism, suggesting that if everything happens, nothing matters. Yet others see it differently. Our universe, with its unique configuration that allows for life, becomes a precious rarity, making our actions, our kindness, our creativity, our pursuit of truth profoundly significant. In 2025, as global challenges like climate change and technological ethics dominate headlines, the multiverse offers a perspective shift. It reminds us that our universe's delicate balance is worth protecting, that our choices shape not just our world, but the legacy of this particular reality. By contemplating the multiverse, we're challenged to act with intention, to steward our cosmic home with care, and to find meaning in the fleeting beauty of our existence. Looking ahead, the quest to understand the multiverse is poised to shape the next era of scientific discovery. As we speak on August 19th, 2025, researchers are planning ambitious projects to probe the multiverse's fingerprints. The upcoming Square Kilometer Array, set to begin operations in 2027, aims to map the universe with unprecedented precision, potentially revealing subtle anomalies that could point to other universes. Meanwhile, advances in quantum computing, with breakthroughs reported by IBM and Google in early 2025, are enabling simulations that test multiverse models in ways previously unimaginable. These efforts aren't just about confirming the multiverse's existence. They're about deepening our understanding of our own universe's origins and possibilities. The multiverse is a beacon, guiding us toward new questions and innovations. So, as we continue this journey, let's stay curious, keep questioning, and embrace the unknown together. Drop your thoughts in the comments. What do you hope future discoveries will reveal about the multiverse? Hit that like button to fuel this cosmic quest, and subscribe to join us as we unravel the mysteries of existence, one mind-bending idea at a time. The multiverse pushes us to confront the boundaries of what we can know, challenging the very nature of scientific inquiry. If other universes exist beyond our observational reach, they may forever remain outside the realm of direct empirical confirmation, forcing us to rely on indirect evidence and theoretical reasoning. This tension echoes historical moments when science ventured into uncharted territory, like when Einstein's theory of relativity redefined our understanding of time and space, despite initial skepticism due to its counterintuitive predictions. In 2025, as we grapple with the multiverse, we're reminded that knowledge often begins with ideas that seem impossible. The pursuit of the multiverse encourages us to develop new tools and methodologies, from advanced cosmological simulations to experiments probing the quantum vacuum state, as seen in recent studies at the European Spallation Source. By embracing this challenge, we not only expand our scientific horizons, but also cultivate a deeper appreciation for the limits and possibilities of human understanding. What does this mean for you? Does the idea of unprovable realities excite you or frustrate you? Share your perspective in the comments. Beyond science and philosophy, the multiverse has become a cultural phenomenon, reshaping how we tell stories and imagine our future. In 2025, the concept permeates popular media, from video games like Quantum Shift to music albums exploring parallel realities, reflecting humanity's fascination with what lies beyond. This cultural embrace of the multiverse inspires us to think creatively about our own world, encouraging innovation in fields like artificial intelligence and space exploration, where multiverse-inspired ideas drive new approaches to problem solving. It also fosters a sense of global unity as people from diverse backgrounds find common ground in pondering the infinite. The multiverse, then, is more than a hypothesis. It's a cultural catalyst urging us to dream bigger, collaborate across disciplines, and reimagine our place in the cosmos. So, what's your take on this cultural impact? Has the multiverse inspired you in unexpected ways?